RC phase shift oscillator using op amp. Here 741, here we use 741 IC. The IC is in inverting configuration. The op amp is in inverting configuration. Here 3 RC sections are there. First RC section, this one is a second RC section, third RC section. Each RC section introduces 60 degrees phase shift. This one is 60, this one is 60. Total phase shift is equal to 180 degrees. The op amp is in inverting configuration. Inverting configuration means some phase shift is there, 180 degrees phase shift. This op amp is in inverting configuration, introduces 180 degrees phase shift. Total phase shift is equal to 180 degrees plus 180 degrees is equal to 360 degrees. Barkhausen criteria condition is satisfied. This is the circuit diagram. Here output of this one is op amp is in inverting configuration. The output of that inverting op amp configuration is fed to the feedback network. The feedback network consists of 3 RC sections, RC, RC and RC. Here the values are R is equal to 3.3 kilo ohms, C is equal to 0.1 microfarad, R1 is 33 kilo ohms, RF is 1 mega ohm. Coming to design, this is the design. The frequency of oscillations of RC phase shift oscillator is F0 is equal to 1 by 2 pi RC root 6. For producing oscillations, that means sine waveform, the gain of that op amp in inverting configuration is RF by R1 is equal to 29, RF is equal to 29 into R1. Let R1 is equal to here R1 is equal to 33 kilo ohms. Therefore 29 into 33 kilo ohms, that is equal to 957 kilo ohms. Use 1 mega ohm part. Therefore here RF is equal to 1 mega ohm part, R1 is equal to 33 kilo ohms. Coming to frequency of oscillations, F0 is equal to 1 by 2 pi RC root 6. 2 pi means 22 by 7. R is equal to 3.3 kilo ohms. C is equal to 0.1 microfarad root 6. After calculations we will get 196 Hz. So this is the board phase shift oscillator using op amp. This one is a gain variation of 741 IC. This one is 3.3 kilo ohms, 0.1 microfarad, 3.3 kilo ohms, 0.1 microfarad, 3.3 kilo ohms, 0.1 microfarad. Here 33 kilo ohms, 1 mega ohm part. This is the feedback network. CR and CR all are connected. Connections are shown here. A is connected to A, B is connected to B, C is connected to C, D is connected to D. Here all these capacitors are 0.1 microfarads. This is 741 IC. The output of the op amp is connected to this one. Display the waveform by using this one. Where is the output? Like that. First find out the time period of the waveform here. Time period of the waveform here 1, 2, 2.6 or 2.7 into this is the 2 milliseconds. 2.7 into time period of the waveform is 2.7 into 2 milliseconds. 5.4 milliseconds. 5.4 milliseconds. F is equal to 1 by t. Therefore 1 by 5.4 milliseconds. 1000 divided by 5.4. This is the practical frequency. This practical frequency is approximately same as theoretical frequency. I think 190, 180, the 1000 by, calculate 1000 by 5.4. We will get the practical frequency. Both are equal. here some disturbance is there. Here by changing this one gain, 1 mega ohm part is used here. By changing this 1 mega ohm point part resistance, will get the pure sine wave. In order to calculate phase shifts, we use a second channel. This is this one, section 1. Here ground is here. Two channels are used here. Here two channels are used here. This is the two waveforms are here. Calculate phase shift. Here the difference between these two calculate here. This is the 2 and this one is 0.2, 0.1, 5, 20, 10, 5, 2. This is the 2 milliseconds. Find out the difference between these two, that is small t. Small t is 0.2, 0.4, 0.6. Small t is equal to 0.6 milliseconds or nearly 0.7 milliseconds. Capital T already determined 5.4 milliseconds. Therefore, phase shift phi is equal to small t by capital T into 360 degrees. Small t is 0.7 milliseconds by capital T is 5.4 milliseconds into 360. That is nearly equal to 60 degrees phase shift. And coming to next phase shift, this is the next one. Here calculate this one is the peak value, this one is peak value, this one is 1, nearly 1. Phi 2 is equal to small t2 by capital T into 360, that is 1 by 5.4 milliseconds into 1 millisecond by 360. We will get another phase shift. And the last one, this is nearly equal to 120. Last one is here for negative peak, positive peak, for positive peak, negative peak. That means 180 degrees phase shift. This is the phase shift calculations. With this RC phase shift oscillator using a op-amp experiment is completed.